Alright, it's Niaki Osteozone. So today we are going to continue with the series. So it's Niaki Chemistry series for the O levels, right? So today we are on the second topic of the syllabi, which is the atoms, elements, and the compounds. So we are going to dissect each and every objective so that you can have a better understanding, so that you can build your foundation in the principles of chemistry, that whenever you are being examined, whether it's a multiple choice paper, the practical paper, or the theory paper, you can still apply, right? So I urge you guys to listen attentively and also remember to subscribe so that whenever we post, you'll be notified, right? So we're going to start. So first we want to define the term atom. So atom is defined as the smallest unit of matter, right? So it is defined as the smallest unit of matter. So the last session we defined matter as anything that occupies space and is a mass, right? So atom is the smallest part or the smallest unit of matter, right? And then we go on to define the term element, right? Element is defined as a pure substance made up of only one type of atom, right? A pure substance made up of only one type of atom, right? And then we go on to define the term compound. So a compound is defined as a chemical substance formed when two or more different elements chemically combine together, right? So it is a chemical substance formed when two or more different elements are chemically bonded together, right? So in this definition, the most important term is two or more different elements, right? So we want to define the term molecule. So a molecule is defined as a chemical substance made up of two or more different elements or same elements which are chemically combined together, right? So it is a chemical substance made up of two or more different elements or same elements which are chemically bonded, right? So we are having two or more, right, different or the same, but for compounds we only have different, so you need to take note on that one. So compound, it is made up of different elements, and then a molecule can be made up from the same elements or different elements. So in other words, we are saying that all compounds are molecules, but not all molecules are compounds. As simple as that. Are compounds. So all compounds are molecules, but not all molecules are compound. Why? Because the definition of a molecule includes that part of a compound, right? And then the definition of a compound doesn't include the same part. Are we together? So a compound is a subset of a molecule from the mathematical point of view, right? So we are now moving to dissect for the further dissection of the atoms, right? So atoms. So atom is the basic unit of an element, right? So we are saying that an atom it is the basic unit, as simple as that. So it is made up of what we call the subatomic particles, the building blocks of an atom. These are what we call the subatomic particles, right? Are we together? So we are saying we have the subatomic particles starting with the proton, going on to the neutron, and then lastly we have the electrons. So these are the protons, these are the neutrons, and these are the electrons, right? So you should know these subatomic particles by heart. You should know these subatomic particles by heart. So we want to dissect each and every of these subatomic particles. So we're going to have the protons. So we have what we call the subatomic table, right? So let us say this is our subatomic table. So for the subatomic table, we're going to have the particle. We are going to have the location. We are going to have the charge and the mass, relative mass. So this is the subatomic table, right? So we are starting with the protons, and then going on to the neutrons, and then lastly we are having electrons, right? So for location of the protons, we are having the protons being located in the nucleus, and then the location of the neutrons, they are located in the nucleus, right? And then the electrons are located in the shells or the orbitals. I can say the shells for junior chemistry. We are going to discuss more of the orbitals for A-level chemistry, right? An orbital defined as the region in space where we are having the highest probability of finding an energy carrying electron. So we have the S, the P, the D orbitals, each orbital having a maximum potential of holding 2 electrons. So we're going to understand when you are writing the nuclide notation in the form of a diagram, right? So the charge of a proton +1, and then the neutrons doesn't have any charge, right? No charge. And then the electrons -1. So P positive, P protons, N neutron, N neutral, neutron neutral, proton positive. Are we together? And then we go on to the relative masses. So the mass of a proton is 1 unit, and then the mass of a neutron 1 unit, and then the mass of an electron 1/1840 units, 1/1840 neutrons units, I mean. So you should know this table by heart. You should know this table by heart. So we are saying that the protons are positively charged, right? And then the electrons are negatively charged. So as you can see, we are having +1 here, and then we are having -1 here. So if you are having 1 proton and then 1 electron, we are going to have an overall charge of 0. +1 -1 gives us an overall charge of +0. So for all the neutral elements on the periodic table, they are said to be neutral. So the number of protons is equal to the number of electrons, meaning to say they have got a zero charge. Are we together? So let us go to the periodic table. So here is our periodic table, the periodic table of elements. So these are what we call the groups. So this is the group 1, the group 2, the group 3, the group 4, group 5, group 6, 7, and then lastly group 8 times group 0, right? So the elements, we are starting with lithium. So this is the number 3. So we have what we call the nuclide notation. So this is the nuclide notation. So it's A and then B here, right? So A is equal to the mass number, right? And then B is equal to the proton number, or atomic number. So what do we mean by the term mass number? So mass number is given by the sum total of the protons and the neutrons. So we said that the electrons are located in the orbitals or the shells with a mass of 1/1840, which is negligible. And then the protons in the nucleus with a mass of 1 unit, neutrons in the nucleus with a mass of 1 unit. So as you can see, the mass of the electrons is negligible, and the mass of the atom is highly centered within the nucleus. So the nucleus is where we are going to find the mass of the atom, right? So together the protons and the neutrons, they make up what we call the nucleon number. So protons plus neutron is equal to the nucleon number. In other words, which is called the mass number, right? So the nucleon number and the mass number are the same thing. So the mass number, which is A from this presentation, A is equal to the sum total of protons plus neutrons, right? And then B is what we call the proton number, the number of protons within the atom, or the atomic number, the number of the atom on the periodic table, right? So for a neutral atom, the number of protons is equal to the number of electrons, like what we have discussed, right? The number of protons is equal to the number of electrons for a neutral atom, the one which doesn't have any charge. So we say the mass of a proton is 1 plus 1, and then the mass of electron is minus 1. So if you are having equal number of plus 1s and equal number of minus 1s, we're going to have an overall charge of 0. So let us say we are having potassium, right? This is the potassium atom. And then we have 19 here, right? As you can see, we're having 19 here. So we're having 19 protons, and for a neutral atom, the number of protons is equal to the number of electrons. And then we're having minus 19 here. And then the overall charge is equal to 0. So for a neutral atom, the overall charge is equal to 0. Why? Because the number of the protons is equal to the number of the electrons. Are we together, guys? So we go on to have what we call the nuclide notation, or the electronic configuration. So this is the nuclide notation. So you can work out the number. So let us say A and then B. So A, we say this is the mass number, and then B, the proton number, the atomic number. So let us say we are given potassium. So here is the potassium, 39. So let me clear so that you can easily see, right? So potassium is K, 39, and then 19. So the mass number is equal to 39. And then the proton number is equal to 19. So we said mass number is equal to the sum total of protons plus neutrons. So we want to find the number of neutrons, right? Because from this information we can only derive the number of protons, the number of electrons, and the mass number. So we can use this equation to calculate the number of neutrons by simply making n the subject of the formula. So mass number is equal to 39, which is equal to P, the number of protons, 19, plus N, the unknown, the number of the neutron. So this one is a simple linear equation, right? So we can simply make N the subject of the formula by saying 39 minus 19 is equal to N. And then 20 is equal to N, the number of the neutron. So this is the formula you need to know for the calculation of the number of neutrons. As simple as that. So you can apply this to each and every element, right? So we are given calcium. So this is the calcium, and we are required to calculate the number of neutrons. So we can simply say that calcium is 20, and then here we are having 40, right? So we can calculate mass number is equal to P plus N, right? And then mass number is equal to 40, which is equal to P, 20 is our P, plus N, and then 40 minus 20 is equal to N. 20 is equal to N. And then the number of electrons is equal to the number of protons for a neutral atom, right? So we want to go on to write what you call the electronic configuration. So electronic configuration is defined as the arrangement of electrons in their electric shells. The arrangement of electrons in their electric shells. Are we together, guys? So we are having so let us write the definition. The arrangement of electrons in their electric shell. So normalize to write electron with this negative sign so that you won't forget that electrons are negatively charged, right? So what are we saying here? We want to write the electronic configuration of let us say sodium. So sodium is number 11 on the periodic table with a mass of 23, relative atomic mass of 23, right? So electronic configuration, from the definition, it is the arrangement of electrons in their electric shells. So we want to write the shells. So we have the first shell with a highest occupancy of 2 electrons. The first inner shell occupies 2 electrons, a maximum of 2 electrons. And then all the other shells are going to have a maximum of 8 electrons. So first we need to fill the first shell so that before proceeding to the next shell, right? So you can only fill the next shell when the previous shell is full. So we said the first shell is filled with 2 electrons, and then the next one 8, the next one 8, all the other shells are filled with 8 electrons, what you call the octet rule. So this is what you call the duplet state, and then this one is what you call the octet state. So we are going to discuss much on that very soon, right? So we are having this sodium. So sodium has got 11 electrons. Since we say the number of protons is equal to the number of electrons for a neutral atom, so we are having 11 electrons here, right? So what are we saying? We are having 8 electrons. So the first shell is filled with 2. So you're going to say 2 electrons. The first shell is filled. And then we are left with 9, right? And then the next shell is filled with 8. So we have 10 electrons now. And then we are left with 1. So this one, we're having 1 here. So this is how you are going to write all the electronic configurations. First, take note that the first shell is filled with 2 electrons. All the other shells are filled with 8 electrons. And always remember, so let me highlight that. Always remember that you can only fill the next shell when the previous shell is full. When the previous shell is full. So for us to fill this shell, we need to have 8 here. We can't go to this shell when we are having 7 here. We need to have 8 here, we need to have 2 here for us to proceed to this shell. So you need to take note of this fact, right? So let us say we are having, so let us stick to the periodic table so that it will sink into your brains as fast as possible, right? So let us say we are having lithium. So lithium is 3 and then 7. So the electronic configuration, the first shell is filled, we are having 3 electrons, right? So the first shell is filled with 2, and then we are left with 1, and then we can write a 1 here. And then we can go on to calcium. So calcium is C, 20, 40, and then we are having 20 electrons, as you can see here. So the first shell is filled with 2, and then we are left with 18, and then the next shell is filled with 8, and then we are left with 10, and then the next shell is filled with 8 again, and then we are left with 2, and then the 2 we can write it here, and we are done. So this is the electronic configuration of calcium. So you can do this to all the other elements. So the first thing you need to know, the first shell is filled with 2 electrons, all the other shells are filled with 8 electrons, and you cannot proceed to a next shell without a full previous shell. And then the previous shell must have 8 electrons. So you can have the electronic configuration for carbon. So carbon is number 6, 12, right? So six electrons here, right? So we can say 2, the first shell, and then we're left with 4. And then we can write the 4 here. We go on to phosphorus, it's P, and then 15, and then that one. So you can say 2 for the first shell, and then we are left with 13. And then we can say 8, and then we are left with 5. And then we can write the 5 here. So what you need to take note of is the first shell, 2 electrons, and then all the other shells needs 8 electrons. So I think it's now clearer for you how to write the electronic configuration. So we have what you call the diagrammatical presentation of electronic configurations. So let us say this is for phosphorus, right? So this is for phosphorus, right? So this is for phosphorus. So phosphorus, we say that this is P, the phosphorus, and then the first shell is filled with 2 electrons, and then the next shell is filled with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8, as you can see. And then we proceed to another shell with 5 electrons. So 1, 2, and then 1 here. 1, 2, 3, 4, 5. So why are we writing? So I think it's clearer for you how to write the diagrammatical presentation of electronic configuration. The first shell, 2 electrons, and then proceed to all the other shells. So this is where you're going to derive your diagrammatical presentation, right? So what you need to take note of is that we are writing electrons in pairs, as you can see. So we defined an orbital as the region in space where we are having the highest probability of finding an energy-carrying electron. So these are the orbital, and each orbital has got a maximum occupance of 2 electrons. So we need to have 2s here, right? And they need to be spaced. So you can't say they need to be spaced. Why? Because electrons are negatively charged. So we need to minimize the mutual repulsions. So the vertical interelectronic spins. So this one will spin anti-clockwise and the other one will spin clockwise. Why? To cancel out the mutual repulsions. So we are going to discuss much on that for A-level chemistry. For now, just appreciate that electrons are shown in pairs and they need to be spaced. Why? To minimize mutual repulsions. As simple as that. For now, just appreciate that. We are going to allude much on that when you are going to do the A-level chemistry. So this is the diagrammatical presentation of electronic configurations, right? So as you can see, we have done electronic configuration. We have explained the nuclear notation. You need to take note on that one, right? So we are going to what you call the ions. The ions, right? So what is an ion? What is an ion? So an ion is defined as a charged particle, right? This is the basic definition of an ion, a charged particle. So we said atoms are neutral. Why? Because the number of protons is equal to the number of electrons. So they will cancel out to give us an overall charge of 0. So we said all the elements on the periodic table, they are neutral. The number of protons is equal to the number of electrons, as you can see, right? Because they are neutral. But we are going to have what we call the ions. An ion is defined as a charged particle, meaning to say we are no longer having an equal number of protons and electrons. It's either we are having more protons than electrons, or we are having more electrons than protons, right? So let us take it for example. We are having 8 electrons, and then we are having 9 protons. So we are going to have 8 minus 8 here, and then plus 9 here, right? Since this one is plus 1, and then this one is minus 1, right? Simple mathematics. Minus 1 multiplied by 8, and then plus 9 multiplied by 1, right? So we're going to have an overall charge of plus 1. It's no longer 0. And then let us say we're having 9 electrons and then 8 protons. So it's minus 9 plus 8. and then we're going to have minus 1. It's no longer 0, it's minus 1. Right? So you need to take note on that. For the ions are going to be classified either positive or negative. Right? So positive ions are what you call the cations. And then negative ions are what you call the anions. So for negative ions, we are having, for cations, we are having protons less than electrons. And then for cations, we are having protons greater than electrons. For us to have an overall charge of a positive, and then for us to have an overall charge of a negative sign. Are we together, guys? So on the periodic table, you mustn't claim this one will give us a cation, this one will give us an anion, this one will give us this, and this one will give us that. You mustn't claim. You must have the understanding of the periodic table. Right? You must have the understanding of the periodic table. So from the periodic table, the group 1, group 2, group 3, group 4, 5, 6, 7, 8. 8 at times it can be called group 0, right? So from group 1, 2, 3, these are what you call the metals. Right? So from group 1 to group 3, these are what you call the metals. And then from group 5 to group 7, these are what you call the non-metals. And then group 8 or group 0, group 8 or group 0, these are what you call the noble gases. And then group 4, we have an anomaly. So we have an increment in the metallic nature as we go down the group. So we are starting carbon. This is the non-metal. So let me highlight on the periodic table so that you won't forget. So this one, these two are what you call the semi-metals. They lie in between the metals and the non-metals. And then carbon is the non-metal. And then the last two are what you call the metals in that group. So we have an increment in the metallic nature as we go to the group. So we're going to discuss much on that when we're doing A-level chemistry, explaining what you call the inert pair effect, the stability of the +2 and the +4 charges. But for now, just appreciate that. Right? For now, just appreciate that. So all the metals. So this one, you need to take note of these points because they're very, very crucial. So group 1 elements, all the metals, they react by losing electrons. They react by losing electrons. And then all the non-metals, they react by gaining electrons. So by losing electrons, we are going to have the number of protons greater than the number of electrons, which will give us a positive charge, what you call a cation. And then by gaining electrons, we are going to have the number of protons being less than the number of electrons, meaning to say we are going to have a negative charge in ions called the anion. Are we together? So non-metals, they react by gaining electrons to form the anions. Metals, they react by losing electrons to form the cations. Cation defined as a positively charged ion. So cation, positively charged ion. And then anion, negatively charged ion. Right? So you need to take note on that one. You mustn't claim this one will form this one will form the cation, this one will form the anion. You mustn't claim that. First, you need to identify, is it a metal, is it a non-metal? So you are going to observe that by simply using the periodic table. in which group is this element? So this one is in group 2, right? So group 2 is the metals, they react by losing, so it is going to form a cation. And then fluorine is in group 7. Group 7 are non-metals, they react by gaining to form an ion. So this one will form a negatively charged ion. So you mustn't cram this. You're going to be given the periodic table in your examination, right? So you mustn't cram this. You must have the understanding. Because at times you'll be given that it is an element X, which is not there on the periodic table. So you must apply. Alright, so we are now moving on to the next session. So the next session we are going to discuss more about the ions, right? So for here we have just introduced the ions, the positively charged ions and the negatively charged ions. So the reason behind the chemical reactions, the main reason behind all the chemical reactions is to attain stability. So the reason behind all the reactions is to attain stability, right? Is to attain what you call stability. So the stable group on the periodic table is the group 8. So all the elements want to have 8 electrons in the outermost shell. So let us write the electronic configuration for sodium first. So sodium, so we have learned how to write the electronic configuration, right? So sodium is 281. And then let's just write that one off. Let me clear on this one so that you can see. Of neon. So neon is number 10, as you can see, right? So neon is 20 and then 10 here. So it's 2, 8. So all the elements wants to have 8 electrons in the outermost shell. Like that one of the group 8 elements. All the elements wants to have 8 electrons in the outermost shell. So this is what we call the octet configuration, having 8 electrons in the outermost shell, right? So all the elements, so let us highlight that, all the elements, they want to have 8 electrons in the outermost shell, what you call the valence shell. The valence shell is the outermost shell, right? So they want to have 8 electrons in the outermost shell. So they will react either by gaining, by losing, or by sharing electrons. So atoms react either by gaining, by losing, or by sharing electrons, so that they will attain the stable noble gas electronic configuration. So this is what we call the stable noble gas electronic configuration, having 8 electrons in the outer shell, the valence shell. The valence shell, right? So we have valence and then valency, the combining power, right? So sodium, we said sodium is a metal. We said metals, they react by losing electrons here, right? So sodium will react by losing this one outer electron, so that it will be left with the outer valence, like that one of a noble gas, right? So if you are having sodium losing 1 electron, sodium will then have 10 electrons. Since in the initial phase sodium is having 11 electrons, it will then have 10 electrons. So to write the formula of the ion, we are simply going to say sodium plus 1. So this plus 1 will indicate the number of electrons that are being lost during the chemical reactions. If you are having calcium, right? Calcium is number 20 and the electron configuration is 2882. So calcium is a metal since it is in group 2. So the group number is denoted by this number in the outermost shell, right? The group number is equal to the number of electrons in the outer shell. So here we are having 1 electron, meaning to say sodium is in group 1, and then here we are having 2 in the outermost shell, meaning to say calcium is in group 2. So calcium will lose these 2 electrons, and then we have this electronic configuration 288, right? So we are having 20 here electrons, now we are having 18 electrons, and then we are having 8 in the outermost shell. So this is the electronic configuration like that one of a noble gas. So this is the electronic configuration of a noble gas. So which noble gas are we referring to? The one with 18 electrons, we simply go straight to the periodic table. The one with 18 electrons is argon. As you can see here, it's argon. Right? So this is how you are going to write all the formulas of the ions, right? So we go on to lithium. So lithium is number 3, right? So lithium, we're going to say 2, 1. So we said we are having these 8 electrons, what we call the octet, and then we can have 2 electrons, what we call the duplet. So for duplet, we are referring mainly to helium. So helium, here is our helium. Helium has got 2 electrons. So this is what you call the duplet state. We refer the duplet state with respect to helium, right? So lithium is in group. Which group of the periodic table? We are having 1 electron in the outermost shell. Then to say lithium is in group 1. And then it will react by to lose this 1 electron, so that it will have 2 electrons in the outermost shell, what you call the duplet state. So you're going to have 2 electrons for the lithium ion. So it's lithium plus 1 plus to indicate that we are having more protons than electrons, right? And then 1 indicating the number of electrons which are being lost during the chemical reaction. Are we together, guys? So this is how you write the chemical formulas for all the ions, the cations in specific. And then we are now going on to the non-metals, how to write the chemical formulas for the non-metals. So we are having oxygen. So oxygen is number 8 on the periodic table. It's number 8 on the periodic table. Oxygen is number 8 on the periodic table with a mass of 16. So the electronic configuration is 2, 6. So we said non-metals, they react by gaining electrons. So how many electrons do we need to gain so that we can have 8 here? How many electrons are we going to gain so that we can have 8 here? So we are simply going to add 2 electrons. So the sodium ion, we have 2, 8. And then the formula is O2 minus. So the negative sign indicates that we have gained an electron. We are having more electrons than protons since we have gained an extra electron. And then this 2 indicates the number of electrons which are being gained. Are we together, guys? And then we are going to explain for fluorine, right? So we go and straight to the periodic table. This is our fluorine, right? Number 9 on the periodic table, right? So fluorine, the 19 here, right? So the electronic configuration for fluorine is 2, 7. So which group of the periodic table? We look to the number in the outermost shell, number of electrons in the outermost shell, 7. So it is in group 7. And then which group is oxygen? Group 6. So this is how you can derive the group number from the electronic configuration, right? So how many electrons does fluorine needs to have 8 electrons in the outermost shell? We need to add 1 electron here. First you have 2, 8, and then we are now having 8 in the outermost shell. The electronic configuration like that one of a noble gas. So the formula is fluorine 1 minus. So at times you can ignore the 1. So 1 indicates the number of electrons gained, and then minus indicating that you have more negative centers compared to positive centers, right? And then we go on to phosphorus, which is number 15. So phosphorus, the electronic configuration is 2, 8, 5. So how many electrons do we need for us to have 8? We are going to have 3. So you have 2, 8, 8. And then it's P3 minus. 3 indicating that you have gained extra 3 electrons. And then minus indicating that you are going to have more negative centers. As simple as that. So this is how we are going to write the chemical formulas of the ions. Now we are only trying to understand the chemical formulas for all the elements on the periodic table. We have what you call the polyvalent ion. For now, ignore those ones. We are going to discuss them when you are into chemical reactions, right? For now, just appreciate these ones. So you need to try to write the ions of all the metals and all the non-metals. Are we together, guys? So we go on to the next part of the session, So we have written the phosphorus ion, that's what we call the phosphide ion. So this is the phosphide ion. So at times you'll be required to give the electronic configuration of the phosphide ion. So you can deduce the number of electrons from the periodic table for the phosphorus atom. So this one is the ion, the anion, right? Negatively charged ion. So phosphorus on the periodic table, the neutral atom is 15. So it's 2, 8, 5. And then we have these 3 minus, meaning to say we are adding 3 electrons here. So it's going to be 2, 8, 8. And then you can be given this one for sodium, 1 plus. So first you need to write that one for sodium. So it's 2, 8, 1. And then we have this 1 plus, which indicates that we are going to lose this one outer electron. For us, you have 2, 8, 8. So this is how you deduce the the electronic configurations of these ions, right? So these are the cations, and then this one are the anions, the positively charged and the negatively charged ions. As simple as that. So we have introduced you to write the nuclear notation and how to write the chemical formulas for the ions. And I think for now you are good to go. So we're going to discuss in the next session how to write the chemical formulas, right?